Hello students, in this video we will see Newton's backward interpolation. In the previous video we have seen Newton's forward interpolation. Now we will see Newton's backward interpolation. So the interpolation is the method of estimating the value of a function at any intermediate value of the independent variable when its values are known only at certain specified points is called as interpolation. So we have seen two kinds of interpolation up to now. The first is a Lagrange's interpolation, then we have seen forward difference interpolation, and this is Newton's backward difference interpolation. Now, the Lagrange's one there, it is useful when even when the data is not equally spaced, values of x are not equally spaced. But for Newton's forward as well as backward, we need equally spaced values of x. Now, why there are two interpolations for Newton's also? Newton's forward and Newton's backward. What is the difference between them? So when we have to find value of y for value of x which is between the lower part of values of x, the lower side or left hand side, in that case we can use Newton's forward interpolation. And when the value of x that we have the value of y we have to calculate for value of x, which if it lies to the right side or the upper portion of the values of x, at that time we can use Newton's backward interpolation. Okay, now let us discuss this Newton's backward interpolation. So let y is equal to y0, y1, y2 all the way up to yn with the values of function y is equal to f of x corresponding to the equidistant points. Again, the points are equidistant. X is equal to x0, x1 which is x0 plus h, x2 which is equal to x0 plus 2h, up to xn which is x0 plus nh. Then suppose it is required to find f of x for x is equal to now xn minus kh for any real number k, and h is a common distance here. Then y at f of x, that is f of xn minus kh. Now we will require the relation between difference operators. So yn minus r is nothing but e raised to minus r yn. So this is a backward shift by r steps. Okay. Then and we have this relation between this shift operator and backward difference operator. So e raised to minus r is 1 minus del raised to r, that we have seen in previous videos. So this f of xn minus kh, now for a minute assume that k is equal to 1. In that case it is f of xn minus h, that is f of xn minus 1, right? So that means the output will be yn minus 1, which is same as operating e raised to minus 1 on yn. So for k backward shifts we have to operate e raised to minus k on yn, right? So which is equal to 1 minus del raised to k y0. Now open this bracket by using binomial expansion. So we get this with alternate plus minus signs here. 1 minus k del plus k into bracket k minus 1 upon 2 factorial del square minus k into bracket k minus 1 k minus 2 upon 3 factorial del cube plus and so on operates on yn. So this is Newton's backward interpolation formula is. This is Newton's backward interpolation formula. Now let us solve one example. So here we have to find the population of a town. Okay, so here the population of town is given for these years. In the year 2000 it is 46,000, in the year 2005 it is 55,000, in the year 2010 it is 66,000, and in the year 2015 it is 80,000. So you have to estimate the population for the year 2012. You can see this number 2012 lies to the right side of this data, right? So that's why you are using backward difference interpolation. Suppose you have to find population in between these two, let's say for the year 2003. In that case we can use forward difference interpolation. Okay, and also find the rate of change of population for the same year. Okay, all right. So here let's find first this backward difference table. So first column will contain all the values of x, second column will contain corresponding values of y. Then this backward difference of y1, which is, so del y1 is y1 minus y0, that is 55,000 minus 46,000, which is 9,000. Del y2, which is y2 minus y1, which is 66,000 minus 55,000, okay, which is 11,000. Then del y3, that is y3 minus y2, and it is 14,000. Similarly, this fourth column will be second order differences. So del square y2 is 11,000 minus 9,000, that is 2,000, and del cube y3 is 14,000 minus 11,000, okay, which is 3,000. And the third order difference, del cube y3 is 3,000 minus 2,000 equals to 1,000. Now here x0 is 2,000, h is 5, okay, xk is equal to x3 minus kh. Basically, actually we need xn here, not x0, xn, because we are using backward difference. So xn, and which is 2015. Okay, all right. So xn is 2015, h is 5, and now xn is nothing but x3 now. All right, because this is x0, x1, x2, and x3. So n is 3 in this case. So k is 2015 minus x upon 5. Now see, for the while solving example on forward difference, we have keep this k as it is, and we got a polynomial in x, and that polynomial we use to find value of y for corresponding values of x. But here, this example we will solve without finding a polynomial. We will directly find a value, that is a population at the year 2012. In that case, we have to put this x as 2012. So in that case, k will be 2015 minus 2012 upon 5, which is 3 by 5. So now this will, if you take a value of k as 3 by 5, it will directly give us the population at the year 2012. And if we use this value of k, 2015 minus x upon 5, this will give us a polynomial which can be used to find value of y at any value of x. So right now we will use the second way. Okay, we will directly go for the population at the year 2012. So this is Newton's forward difference formula. Now put all these values. So after substituting all these values, it will give us y is equal to 71,184, 71,184. So this is the population for the year 2012. You can see here this number lies between 66,000 to 80,000. So this is how we can use this Newton's backward difference interpolation to find values of y at corresponding values of x. Now the first part is over. In second part, you have to find the rate of change of population also. See, while solving the example on forward difference, there we got a polynomial. So we could easily differentiate that polynomial and find derivative. But right now we don't have polynomial here, right? So when there is a we don't have polynomial, then how to find the rate of change? So for that, so this is our Newton's forward difference polynomial. Now we have to find dy by dx. Now see, as y, here y is in terms of k, and k is a function of x. It is 2015 minus x upon 5. So right now y is a function of k and k is a function of x. So therefore by chain rule dy by dx, that we have to find, right, rate of change of population. So dy by dx is dy by dk into dk by dx, which is dk by dx. From this it is minus 1 by 5 times. So minus 1 by 5 times dy by dk. So therefore dy by dx will be minus 1 by 5 times. Now we'll differentiate this polynomial here with respect to k, which is this derivative of y3 is a constant with respect to k will be 0 minus del y3 plus. So open these brackets and differentiate it. So it is 1 by 2 into bracket 2k minus 1 del square y3 minus 1 by 6 3k square minus 6k plus 2 del cube y3 and so on. So this is a polynomial for derivative of Newton's backward difference interpolation. Now let's put all these values and we get dy by dx at x is equal to 2012 as 2722.66 per year. So this is a rate of change of the population for 2012, 2722.66. So this is how without finding polynomial also we can calculate these values. Alright, now the same example you can solve using forward difference table also. Even if you are finding value for 2012 which lies in the right side, but for the same example we can use Newton's forward difference interpolation also, and that will also give us a same answer. But why we are using this forward and backward then? Because when you are not finding a polynomial, in that case if you are using the method that we have used here, directly putting the value of x, in that case if the number lies in the right hand side, the difference between these two successive numbers is less, and therefore we have small numbers for the calculation. Instead of this, if you use a forward difference for 2012, in that case difference between 2000 and 2012 will be 12. Comparatively it is more than the difference between 2015 and 2012. So that is the only difference. To simplify our calculations, we use these methods interchanging. You can Newton's forward and Newton's backward. Otherwise, both methods will give us exactly same answer. Thank you.